Welcome. We're going to take a look at multi-agent coder, which is an architect, a coder, and a reviewer, which work in tandem and communicate with one another to produce right code iteratively. When we run this, we get this, are you providing query or code? We're going to select query. So we will ask it to build a scientific calculator in tk-inter. When we do this, the architect begins with a design. So it's going to create some maybe pseudocode, some ideas and plan for a coder to work on. This is going, we can actually take a look at some of the examples as well. See, it gave some design elements and it's writing some pseudocode for a coder to work with. This sometimes works great and sometimes not so much. This is more of an experiment I did. I will be reviewing the code extensively. I think there are some great ideas which you can use to build upon. And I have some experiments I have performed, like the jump platformer, snake, space shooter game. We'll be taking a look at. But once the architect is done, it sends its message to coder, and the coder starts writing the code. And now we're going to save this after it's done. And then a reviewer is going to review it, then send it back to architect. Architect will inform the coder. So we will repeat this until max iterations is reached. I originally wanted to have some user feedback intervention as well, but I couldn't get it to work properly, so I just left it in as a commented out. If you do end up downloading the code, please feel free to work on it in this way. Like I said, this is a bit of an experiment for me to work on agent interactions. I'll be making more videos on this as I improve them myself. And as you see, after the coder is done, it has written its code here, and reviewer is going to review and send some feedback. We can actually run this by splitting our terminal here. We can start a new command prompt. This is a good way of actually running your code side by side. Let's run this code and see what it does. Okay, here we go. We have a, say, 5 times 5 equals 25. Its log is this. So all of the buttons seem to be working. That's good. We got something good to begin with. Let's see if it'll introduce some improvements. This is going to go for 3 iterations. Code files for this project will be available at the $9 Patreon tier. I also have over 130 other projects there if you'd like to take a look at it. You can also find all my videos and search them conveniently at my website, www.ecohive.live. You can read their descriptions and also find the code download links. All the links to my Patreon and to my website will be in the description. So while this is going on, we can actually take a look at some of the examples. Let's start with the space shooter. Before we begin, I just want to say all the progress is saved to the history.json file, so you can keep track of it and see what is happening. It's currently being done with the history.json, our current project as well. Anyway, let's run the first file for the space shooter game and see what we got. As you see, it got it right the first time around. There's no keeping track of scores or anything like that, but it works. Let's see what the second iteration looked like. This one seems to have some error here because it didn't fill out all the code, but then on the third iteration, it was able to, and it wrote almost 200 lines of code. So that's actually good. So let's run the final iteration. And this time we actually, oh, game over. Okay, so we did a game over screen, which is nice, but it also is actually keeping track of the score. I don't know if you see in the middle, and we have lives that is present over here, which is off to the side. But anyway, so this is how it works, and the bullet actually goes through enemies once it hits. And it says press a key to play again, but it shuts off. So it can, what I found out is that the system can write much larger, much bigger lines of, much larger code base, right, in a single file. I've seen it write almost 200 lines of code because it's getting quite the detailed design element from the architect. So that's something to keep in mind. And let's see, our second iteration of the calculator is ready. Let's run this. Okay, we got this. It looks, there's more things, like you can now actually put in brackets and stuff. So that's cool. It added more stuff, but maybe it'll fix the layout. Let's see what happens with the next iteration. In the meantime, we can start reviewing the code, see what we are dealing with. So we begin by doing our imports. Really, the only imports we need is OpenAI and term. As far as the packages, you might have to pip install. And then we have this class. Okay, before we talk about this class, I just want to mention that I have actually worked on this project step by step. So MAC stands for multi-agent coder, basic one. So this numbering kind of displays where I started and second step and third steps. These all have different abilities added to it. So there's a big jump from the 3 to 4. But at least if you download the code, you'll be able to see my thinking process. I'll be making a separate video on how I tackle large projects step by step. But this, I wanted to have this as well, so you can actually take a look. I'm not going to review the progression files, but we're only going to be looking at the final file, which is multi-agent coder 4. This 4 represents where it stands in the progression of things, okay? So we have this GPT agent, which essentially is just responsible for making an API call, either in a streaming fashion or not. This is how we're able to print everything to a terminal. And it also has a max character count for dropping messages. Let's begin in the beginning. It gets a role name, a description. That is the role name that we are going to give to each instantiation of this class, such as architect, coder, or reviewer, and a description for that, which we are going to populate the system message with. As you see, we have a system message, which is generally defined here, but we are also inserting the role and the description in the system message as well. We're going to take a look at it. Are the system messages. We are able to say programming system.create agent because we are instantiating this class as the programming agent. Anyway, here is our get response, which takes a user input or stream true or false, takes in a user input. If stream is true, then prints the stream. If not, then it will not print to the terminal. We are using GPT-4, and we are actually done with our code. Let's actually run it and see what the final version looks like. Okay, it did not fix the layout, but everything, I think, seems to be functional. Like I said, it's a hit or miss. It's able to code much more complicated stuff, but it also works well with 3.5 Turbo 16K if you want to try it with that. Anyway, so this is pretty straightforward. This class is just responsible for making a GPT call based on a role and description. We start by counting the characters. I'm just doing this message dropping to fit everything into context limit if the iterations go on long enough. The context window by just using characters. I'm assuming 4 characters makes a token roughly. So I'm dropping earlier messages, except the first 2, right? The first message is the system message. Second message is the user message. But I'm dropping the third message continuously until we are below this 25,000 character limit. This is what that does. And now we're just simply here appending the response. We have a history class, which keeps track of the history by source, target, and message. This is what we are using to save it to a file, history.json, so you can keep track of what's happening. And we have a display method. If you want, it will essentially just print it at the end. I have that method, but I'm not using it. And we have another class called multi-agent system, which is going to actually generate our agents and histories. Save it as a create agent method, which uses the GPT agent class, which we have just looked at with a role name, description, and color. Color is so that when we're printing its responses using term color, we can actually print each one of them separately dynamically. Okay, there's that method, and then get agent response. The get agent response is interesting, takes in a role name and user input. So I was originally planning for this to be automated, meaning that each agent decides to consult with the other, but then I went on a more programmatic approach. So I'm taking it one step at a time. I want to make this fully automated, including with user intervention in the future. Anyway, if we don't find the role name, we say we don't have no agent with that name. Then we get a response of that agent with the role name, with the get response, with the user input. And then we add the user role name and input. History, we add the role name, and then we just save the JSON, which are all methods that are under the history class. Okay, there's a simple misunderstanding here. I just didn't fix it. It just says, for example, when architect is sending its message, it's assuming that it's sending its message to the user. This should actually be coder. In essence, it is responding to us because for coder, architect is the user. If you think about it in the chat messages list, architect would be the user for coder. So you can think of it like that. Change it if you like. Anyway, this works to write the history, no problem. And then we have our main function, which has a recursive function defined in it, which is code extract. I am prompting the coder to return code blocks in this delimiters, code and /code, but it ends up returning it sometimes in Python too. I'm checking for both. We are checking if it's the final iteration, because if it is the final iteration, and we get a code block that doesn't fit the schema, we make another call saying that please return the entire final code and code block, right? Just make another message, and then we call this function again recursively. This is pretty cool. And then we are instantiating the history and programming system from our classes, which we have defined. Then we are creating an agent, programming system, that create agent, architect. This is the role, and this is the description. You can read it by pausing the video if you like. Second one is the coder. As you see, it's instructed to return code in these blocks. And third one is the reviewer. Okay. And then we take in user input, asking it to provide either a query or code. Original idea was that you can either ask it a question or give your code and ask it to work on the code that you already have. You can do that. I haven't tested it extensively. It should work. If you do type in Q, we just take in straightforward user query and with a single line user input. If you type in C for code, then we switch to multi-line input, which you can end with typing done and enter on a new line, because you cannot paste multi-line input to this regular input, single line input. So you do have to do this. Then we define max iterations. And then we enter the loop with the max iterations, this underscore representing which iteration we're on. We check if review is in local. That is because if you think of the way this is going to go, the architect talks to coder, then coder talks to reviewer. This completes one cycle. Okay, so at the end cycle, the final response is going to come from the reviewer. So we will have a review. So we are going to check for that and do something. But more importantly, I have realized that when this iteration keeps going for a long time, maybe 5 times or something like that, and user query ends up being at the very beginning of the messages list, and agents seem to sometimes forget what the original objective was. So that's why I'm checking if there is a review in locals, which means that we have at least completed one iteration. Then I'm actually inserting original user query back into each one of them as a user message, just to keep it aligned with our purpose. And then we get a design by calling the architect. Yeah, so in this case, so maybe I should do this. So this is if review in locals, meaning we have a review variable, then this is what it means. Then we are doing this. But really, at the beginning of the program, this is what we're doing. We are getting a design initially by calling the architect with the user query. And then we append it to the reviewer's messages, because the architect is going to send its design to the coder. This is what it's doing. See, we first get a design and then code by calling the coder with the design. We say this is the architect's design. But by the time the coder gets back to the reviewer, architect's original design isn't going to go to the reviewer. So that's why we're inserting it into reviewer's messages. Because each one of these agents, architect, coder, and reviewer, is a separate instantiation of the class. They each have separate message histories. So that's why here I am inputting the architect's design into reviewer, so it will have information about that. Then we get the design, which the architect returns, and ask coder the code from that design. Then we get our code, and then we append it to the architect, because this code is going to go to the reviewer, right? And to get a review, as you see here, review this code. What are some of the missing parts, if any? Are there any errors, issues? And here is the code. But since the review is going to go back to the architect that will not have direct access to the code, that's why we're appending it here. For the same reason we have appended the design to the reviewer. Okay, so we get the review. And since the review is directly going to the architect, we are appending it manually to the coder's messages so that it knows about what the reviewer has said. And then here we check if we are in the last iteration. Because the last message of the last iteration is going to be a final review, we do want to generate one final code. And we say, please return the entire final code so that we can have this final code block for a final improvement. And now we're calling the code extract function. That's why we are here having the last iteration true parameter. Okay. After one iteration of this is complete, then we will have a review in locals. That means we will have a review variable defined due to reviewer having returned a review of the code. Then we can engage in this part, which is essentially appending all the user messages and getting a design from the architect. And then we just run the main function like this. If you like, I'll run this in debug mode too, so you see exactly what's going on. If you're interested in finding out exactly, I'll just go ahead and put some breakpoints and run it in debug mode. Actually, when running, so we're going to run this code in debug mode. You can do that either in Visual Studio Code by pressing F5 or coming to this run and debug part and clicking on Run Debug. And we can actually come here next to the number lines and put breakpoints. When you're running your code, you can put breakpoints anywhere, but if you're going to run a class or a function or a method, it's best to put breakpoints inside, because otherwise it will not enter inside of the whatever's happening inside the method in this case. So I'm just going to put a breakpoint at each juncture. And let's put one here. We're going to maybe put one here, and then let's put get agent response right here, and then let's put some in our code extract function right here, and then this is our main loop, so we can actually see what's happening. So this is about it. So all I have to do is now press F5 and run this with the debugger. As you see, we've stopped at line 118 because the first thing that happens when our main function is run is that we skip over the code extract because we are actually we've just defined it. It hasn't been called yet. So we are defining a history instance, programming system. See, here we are instantiating these classes by going over. And now we are creating the programming system create agent. And we're going to go and do that. Once we are defining an agent, we enter the GPT agent class. Remember down here, we are calling the create agent with the architect and a description. This is what it's going to be. You see the role name is architect and description is its description. That's how we are assigning all these, and its color is going to be blue. And then we assign the system message, and then we have created the architect. We're going to do the same thing for the coder. I'm just going to roll over these. And now we are at, are you providing a query? Or we are in line 151. Should have put a check mark over here. And we are going to say Q. And then it says enter your initial query. I'll actually type in something like a to-do app in TK enter. And now we are entering the iteration for loop with max iterations of 3. And then we check if review is in local, which it is not at this time. So we jump into else. So we're now going to call architect to get a response. We get to get agent response. If role name is not in software agents, which it is, then we're just going to get a response right here. We get into the method get response. We are appending the user input, which is a to-do app TK enter. And response is empty. We are entering the stream, and the rest is pretty straightforward. This is a regular GPT call, and the architect has started. Something interesting to note that this is, I think, useful, although sometimes it fails, because it's creating this entire plan, which makes GPT to create much more complex applications. I think it needs some additional, which I'm not sure exactly what is, but I'm going to be working more on this. If you do download the code and work on it, please let me know at the Discord, which you can find the link to in the description or as a comment here as well. Now that we got the architect's design, we come to total characters. We set it to 0. We set max characters, and we're going to loop over all the messages and check how many characters we have so far, which in this case is 800. And we check if this is more than 25,000, which it is not. We're going to skip and add this to the messages list and return the response. And now we're going to add it to the history as the architect role and with the input, user input. Now we enter the history's add method. We are appending each one of these. See, the message is a user message. And then now we are going to add the response architect and whatever it responded with. We're going to do exactly the same here. Okay, and then we're saving it to a JSON file. And when we do that, now we have written it to the history.json. Okay, this is going to continue and get populated. So this is in a nutshell how it works. Then we move on to reviewer, and then you can run the code in debug mode like this. You can use the step over or F10 for line by line execution, and you can use the continue F5 to jump from one breakpoint to another. I hope you enjoyed this. Like I said, please check out Echo Hive AI Academy. It says 140 plus. I just have to update the website. There's almost over 200 free coding videos everywhere. Everything from LangChain to HTMX, Tailwind, web apps, llama index, all kinds of experiments which you might enjoy. Also, if you're feeling generous and want to experiment with these code files that I'm generating, please become a patron. Thank you for watching, and I'll see you in the next video. Let me know what you think of this. Have a great one.